Good morning, everyone. My name is Calvin Ng. I'm Professor of Faculty Engineering and Applied Science at the University of Regina. Now, the topic of my presentation is design of a conceptual water distribution system for the village of the Meath Park. I'm presenting the project on behalf of our environmental students, engineering students, Miles, Jack, Jay, and Samson. Now, the student team has selected the village of Meath Park as their study area. The town is relatively small with aging water distribution pipes. Universal access to clean water and sanitation is one of the 17 global goals for sustainable development. According to the Saskatchewan Water Security Agency and the Ministry of Environment, the water main of the village is old and deteriorated and should be replaced as soon as possible to minimize health risks to the residents. The goal of the project is to design 3 different water distribution systems by considering different aspects, which including the technical aspect, the economical aspect, the social, and the environmental aspect. Now, the whole idea of including multi-aspect is actually the idea from the team. The team want to make the decision as comprehensive as possible. The 3 designs are then compared to recommend the best system. Okay, thank you very much. Now, our student team has proposed 3 water distribution systems, as you can see from the table. We have the looped system, the bench system, and the combined system. Now, the combined system is simply a combination of the looped system and the bench system to take advantage of the both systems. Now, for all 3 different designs, it is very important to look at all of the proposed systems by the student team are able to provide sufficient water to all households and buildings. The decision matrix is shown at the upper left-hand side of the slide. So the technical aspect worth about half of the total score, about 50%, economical aspect worth about 35%, and environmental aspect and the social aspect worth about 10% and 5% respectively. If you look at the bottom row of the table, which highlighted in yellow, so the very last row of the table, the weighted rents are identical for both the looped and combined system with a score of about 1.95. Now, because the weighted rents are similar, the total rank is also considered by the student team. The total rank of the combined system is 7, less than the looped system. Therefore, the combined system is recommended. So, sorry about that. Can you go back to the previous one? Yeah, I just want to show you the design. Yeah, I just want to show you the design by the student team. So if you try to look at the lower left-hand side corner of the slide, you can see that the loop system is used for the commercial area and a bench system is used for the residential area. I apologize for maybe the figures is a little bit difficult, too small to see. So I apologize for that. So if we go to the very last slide, now this table actually shows you the specifications of the recommended system. The estimated pipe length is about 16,400 feet or about 5 km. The project cost is about $866,000, and the estimated surface lifespan of the combined system will be about 22 to about 30 years. Now, in conclusion, the student team has considered 4 different aspects, technical, economic, social, and environmental aspects to promote sustainability in engineering projects. We believe the project outcomes have helped to address the deteriorated water main issue and also the health issue of the rural areas that are often ignored. I hope you enjoyed this short presentation and thank you very much for your time.
Thank you so much, Kelvin, and it's great to see you working with small communities in Saskatchewan. I think there's a lot of innovation happening there.